The speed of sound.
We're gonna do this thing. Alright, so here we are. We're gonna test the speed of sound today in air. We're gonna do a pretty easy test. We're gonna make a really loud sound pretty far away and time it and try to figure out how fast sound is in air. So I'm gonna go down all the way as far as I can from here, and you guys just have to listen for that.
Here we go.
So, after finding our time, we can find our distance on Google Earth, and I got about 190 meters is how far away I was standing. Then we could take some of our variables and plug them in to v equals d over t to find our velocity, and I got 190 meters divided by 0.57 seconds, which is 333 meters per second.
So we figured out how fast sound moved in air. I wonder how fast sound would move in solids next.
Why don't you make a prediction? Will sound move faster or slower in solids?
Alright, here we are, filming the speed of sound in solids. I picked a steel pole, just had a hammock stand lying around. It is 5.1 meters long, and here's the setup. So on here, we have graphical analysis opened. We have our two microphones going out, one to that end, and the other to the other end, 5.1 meters away. We're going to take our science hammer, and we're going to strike one end. What I'm predicting we'll see is that this microphone will probably register sound immediately, while the one on the other end there will take a little bit of time, a very little bit of time, to register another sound. And we're going to try and measure the speed sound takes to go from here all the way down to the other side. Alright, let's see what kind of data we can get. Science hammer. I'll hit this side. Oh, gotta make sure we press collect. Collect. Ooh, that's some good data.
Here's the data we collected. If you look on the left side, that's the microphone that was closest to the hammer when I hit the pole. The peak on the right side is the far microphone. The time it took to go from the close microphone to the far microphone was 0.00083 seconds. All right, time to do a little bit of calculations. So again, I'm going to do v equals d over t. My distance was 5.1 meters, and the time it took was 0.00083 seconds. I get a velocity out of 6,144 meters per second. Let's see how close we got. Quick Google search found that the speed of sound in steel is 5,960 meters per second. So I would say we were pretty close with that. Now, why do you think the speed of sound in solids was so much greater than air? Molecule to molecule distance is way smaller in solids. We can kind of see it in this PhET simulation. If we click on gas, we could see that the molecules are all spread out. It would take a long time to get sound to go from one to another, compared to if we went to liquids, where molecules are a lot closer. And even more so when we go to solids, Molecules are very close together, and they would transfer information very quickly. We could see what having closer together molecules do for the speed of sound. In solids, it moves a lot faster, because my dominoes are much closer together. Then liquids was a little slower, and then gases were the slowest. So, why do we care about the speed of sound? Well, oceanographers use it to map the bottom of the oceans. They could send sound waves down and time how long it takes for the sound waves to come back. And if we know the speed of sound, we can figure out how deep it is. And they can find irregularities. So why don't you guys think about this? If we have a known depth of the ocean and it took 1.25 seconds to receive a signal back, what would the speed of sound be in water? Now it's a little tricky. Here's the tricky part. If it took 1.25 seconds to return, that means half the time was spent going down and half the time was spent going back. So we're either going to have to double the distance or half the time. In this case, I doubled the distance. So 2 times 935 meters divided by my 1.25 seconds. I get a velocity of 1,496 meters per second. So let's try another one. If I have an unknown distance, but I know how long it takes to reach the bottom of the ocean and get a signal back, if it takes 4.34 seconds, let's go ahead and half that time. And I know the velocity from the last problem. Well, let's try to find the distance. Why don't you guys try it on your own? We get a distance of 3,246 meters. The act of using sound to locate things is called echolocation. Some animals can even use the speed of sound to help them find food. We see that bats can send out clicks, and they listen for the echo coming back to see how far away prey is. Geologists can also use it to map the interior of the Earth. It's how we realize that we have a solid inner core and a non-solid outer core. Thanks for watching.